Welcome students, and we are going to learn some system of equations in this part of the course. So in the next part, so this is after the mid-sem essentially. What you have is we want to study the system of ODE. Okay, so first of all, let us understand what a system of ODE means. So essentially we are working with something like this. So for now I am just restricting myself to 2 cross 2 for better understanding. Okay, otherwise you can just think of the same thing for n cross n. So I will just restrict to myself to 2 cross 2. You can do it for n cross n. Okay, but let me put it like this, but the same holds, same holds for n cross n. Clear? So how do I go about it? What is the definition of a system of equation? So you have an equation which will look like this. Capital Y prime is equals to some function of small x, this is the variable, and capital Y, okay, is said to be a 2 cross 2 system of equation, if you break it up. How does it look? If y, capital Y, see this capital Y, this is a vector valued function, in the sense that y depends on x, okay, and that is given by y1 of x and y2 of x. Clear? If yx looks like this, where y1 yi prime, okay, sorry, not yy prime. So essentially every function yi, okay, every function yi, these are functions from wherever x is defined. So let's say from the interval I to r. Clear? So see, for each x, what is happening here is you get a vector valued function, in the sense that for every x you get a vector, right? It's a 1 cross 2 vector, right? It's a 1 cross 2 vector. Okay. Okay. Yi is from I to r. Sorry, this is the transpose. I have to take a transpose. So yi is from I to r, is a function, and you are defining a capital Y which is from I to r2. Okay, so if y from I to r2 is given by this one, where yi is from I to r and capital Y prime of x, okay, that is defined by y1 prime of x. So this is what I am defining. Yeah, it's not like given somewhere or you can get to prove it. You can't. This is what I am defining. So y prime of x is this, and capital F of x capital Y, that is given by f1 of x y1 y2, f2 of x y1 y2. Okay, so f is given by this with fi's known function in I. Clear? So they are known function in not essentially. So they are known function in I cross r. Let's just put it this way. Okay. So fi's are function in I cross r, and this is the first component, second component. So capital F is a 2 component function. Okay. So again, capital F is a function from I cross r to r2. Clear? Okay. So essentially what we are looking at is equivalently, you can just write it like this. So equivalently you have an equation like this: y1 prime equals to f1 of x y1 y2 y2 prime equals to f2 of x y1 y2. Okay, so that's the system of equation. It's a 2 cross 2 system of equation. Okay, it's a general equation. So this is a general 2 cross 2 system, general 2 cross 2 system. Okay, so and let's call it 1. Let's call the system 1. Now 1 is cooperative. It's called a cooperative system. So you understand, cooperative means it cooperates with us human better. So 1 is cooperative system if fi of x y1 y2 is independent of yj. Okay, I not equals to j. So essentially what I mean is f1 of x y1 y2 is independent of y2, f2 of x y1 y2 is independent of y1. You understand? So so essentially the equation, that is, therefore the equation will look like this: y1 prime is equals to f1 of x y1. Okay, so essentially it will be a set of two independent ODEs. y2 prime equals to f2 of x y2. Okay, clear? Okay, so and if that's not the case, then it's just a non cooperative system. Okay, otherwise, so let me put it this way: otherwise 1 is non cooperative. Yeah, fine. Now let us look at, so we understood what a system is. It's actually bunch of two ODEs which are just put together in a way that it may or may not, involve each other's variable. Okay, so generally it will actually involve, otherwise it's just a bunch of two ODEs put together. Clear? Yx, and so this is also clear. Yx I am defining it like this, yeah, and y prime x also I am defining it like this: y prime of x is y1 prime y2 prime. Okay, here in system you have to keep this in mind. See, this sorry, yeah, this since we are writing it in a, when you write it in a matrix notation, clear, make sure that you follow the the size of the system. Yeah, now let's say that if you want a system, so let if I of x y1 and y2 looks like this: ai1, okay, y1 plus ai2 y2, I equals to 1 and 2. If you can write fi like that, then this equation will turn out to be y1 prime, let me write it together, y1 prime of x, okay, this is a11 y1 plus a12 y2. Clear? And y2 prime of x will look like a21 y1 plus a22 y2. Clear? Okay, now this is an example of a linear system. Clear? So let's call it 2. Okay, so 2 is said to be a linear system. I will explain to you how it is linear system. So you see, whenever I say It's not like for this course, but for any course, whenever you hear the word linear, it means linear with respect to something, some variable. Yeah, here we'll try to understand what variable is that. Now 2 can be, so 2 can be rewritten, okay, 2 can be rewritten as y1 of x, y2 of x, like that. Yeah, this is equals to a11, a12, a21, a22. That is a 2 cross 2 matrix, right? Okay, so I can write it like y1 and y2. Of course that depends on x, okay, that depends on x. And please remember this thing, a11, a12, these are, this may be constant, this may not be constant, they can be functions of x also. Okay, so in general, let me put a small note here. In general, aij, okay, can be functions of x. Clear? They can be functions of x. They may not be a function, but they most certainly can be a function of x. Okay, now if I write it like this, see, essentially, so this is a 2 cross 1, right? So this is a 2 cross 1. Okay, fine. Now you see, if I use our notation, it means that is capital X, and this, let's say this is a, for now let's just assume that this is constant. Okay, for now let's just, so assuming it is a constant, assuming aij are constants. Okay, for now, just to make life a little easy, that's your a. Yeah, let's call that a. So this is your a is a1, a2, so this whole matrix, this is, that's your a times, so this is y prime, and that's your y of x. Clear? I mean, a does not have to be constant, a can be a function, and in that case you can just write